We have the indefinite integral of the tangent to the 7th power of x over 2 times the secant squared of x over 2 dx. And we're going to use substitution. You could do two substitutions here, I guess, if you really like to do that. I don't particularly care to. I would rather just let u, since I know the derivative of the tangent of x over 2 is something with the secant squared of x over 2, I'm going to let u equal the tangent of x over 2. And then du would equal the secant squared of x over 2. And I have that times the derivative of the argument, which is the derivative of x over 2, which is just 1/2. Remember, that's 1/2 times x. And then, of course, that's dx. So I actually have secant squared of x over 2 dx right here in my integral. So I'm just going to say that 2 du will equal the secant squared of x over 2 dx. And then when I do that, I can make my substitution. I can say that now the tangent of x over 2, well, I said that was u, so I have u to the 7th. And then secant squared of x over 2 dx is just 2 du. So I'll just rewrite that a little bit. Oh, well, why don't we just factor out that constant while we're at it? Du, and then we'll integrate u to the 7th, so we'll go up by power 1 over the new power, plus c, 2 over 8 is 1 over 4, and u is the tangent of x over 2, and then that'll be to the 8th power. I didn't really want to write it in there. I think it looks better that way. So anyway, there you go. Pretty straightforward problem if you know your derivatives. A lot of these are. They're really not that difficult. But you just gotta, it's really just practice. I suggest probably doing all the problems in this section of your textbook, you know, that are just straightforward, like these, or, well, that are just basic integration. I don't know. Actually, it would be good to do all the problems in every section of your textbook.